Hey everyone, welcome back to the channel. Today we're going to be talking about combining two inequalities. Let's get started. Alright guys, before we hop into combining two inequalities, we have to know two things. Can you solve an inequality and can you graph it on the number line? That's what we're doing here. So here we have negative 6x minus 10 is less than or equal to 8, and we have our number line. If you think you can solve it, go ahead and solve it and graph it as well. If not, let's do it together. All right, so here we have negative 6x minus 10 is less than or equal to 8. Already I'm thinking I have a coefficient that's negative, and I have an inequality symbol. That tells me at the end of this, I'm going to have to flip the sign, because in math, we know that whenever you have inequalities and you have to divide or multiply by a negative number, you have to flip the sign. So let's go ahead and put that into good use. So we're gonna add 10 to both sides first to get rid of our 10, because the goal is to get x by itself. And we have negative 6x is going to be equal to a positive 18. Now with that being said, we're going to divide by negative 6x, and remember, this is a less than or equal to sign. So we're going to divide by negative 6 on both sides. Divide by negative 6, and that's going to leave us with x is going to be, now remember, we're flipping the sign because we divided by negative. X is going to be greater than or equal to a negative 3. All right, so now that we have that, let's go ahead and clean our workspace. But we still have to graph it, right? We still have to graph it. So let's go ahead and graph it. So x is greater than or equal to negative 3. So negative 3 is our starting point. So I'm going to circle the point above it. But am I going to leave it open or closed? Leaving the circle open is only for inequalities that does not have the bottom line, or in other words, an or equal to sign, right? So it's just going to be less than or greater than. If it's greater than or equal to or less than or equal to, we bubble in the sign. So we're going to bubble in the sign because all the values are also including our negative 3. Now we're going to go in what direction? Well, x is greater than negative 3. So we're not going to go backwards, we're going to go forwards. So we're going to keep going forwards. All numbers greater than or equal to negative 3 are going to be fit for this inequality right here. And let's put that to good use. Let's say we get 0. Negative 6x times, or negative 6 times 0 is going to give us 0, and negative 10 is less than or equal to 8. Now let's try a number opposite this rule to check. Negative 4. Negative 6 times negative 4 is going to give us a positive 24, and 24 minus 10 is going to give us 14, and 14 is not less than or equal to 8. So therefore we know that our answer here is correct. All right, so now we can go ahead and jump into combining two inequalities. The first step is to notice, are we looking at an and or an or? Why do I say that? That is the key element to knowing how to combine your two inequalities. If you have an and question, that means you want to look for all values that satisfy both inequalities. So that means, let's say one inequality allows for all values greater than 10. And this equality allows for all values greater than 20. So now, even though maybe values like 11 and 15, for instance, qualify for this inequality, they don't qualify for this one. So we have to make sure that the values we get satisfy both inequalities. That's why I put both have to be true for and questions. If it's an or question, that just means that you're going to go ahead and combine both inequalities on the number line. And I'll show you that later, but basically one inequality has to be true at all times. All right, so now let's hop in. So first we're going to go ahead and solve this. So subtract 5 from both sides. You're left with 4w is less than 4, and w will be less than 1. So just some quick math really quick, and subtract 1 from both sides. We're left with 2w is less than or equal to 12, and w is going to be less than or equal to 6. So now we have our solution sets for the both inequalities. Now we have to find out which values satisfy both inequalities. All right, so here we have w has to be less than 1. All right, so let's put 1 right here. Now every one of our values going this way has to be less than 1 in order for it to satisfy this inequality. Here we have W has to be less than or equal to 6. So let's put 6 right here. And everything going on this way will satisfy this inequality, right? And remember, our less than or equal to sign, that's going to be a big bubble in. This one is just going to be a circle because we just have less than 1. All right, so now we have to find the values that satisfy both inequalities. I can't stress this enough since we have an and equation, all right? How do we do that? Well, we have 1, so now it's really just logic and reasoning, right? So we have to find the values that satisfy both of these, all right? So everything less than 1 can also be right here, because if I put this inequality in this right here, our 1 would probably be right over here, all right? And then we just have everything to the left of 1. So therefore, from maybe choices, I guess you could say 2 all the way to 6, 2 through 6 don't satisfy this inequality. So let's say a number like 3, for instance. 4 times 3 is 12, and 12 plus 5 is going to give us 17. And 17 is not less than 9, right? Hopefully you understand that. So now we move on with everything less than 1. All right, because it has to satisfy both equations at all times. So our answer is going to be right here. W is less than 1 because it has to satisfy both inequalities at all times. So, oh, sorry, this is supposed to be, this is supposed to be a 1. All right, so basically everything to the left of 1 is going to be our answer choice. So therefore, this is what our answer would look like. All right, guys, let's go ahead and try out another problem. So here we have 3y minus 3 is greater than 15, or 2y plus 1 is less than or equal to 7. Now, how do we find our way throughout this problem? The first thing we have to do is recognize the or. With an or problem, that basically means that any given point on the number line, one of the equations or inequalities has to be satisfied. All right, so let's put that to good use. So first off, we're going to solve both of our inequalities. Plus 3 on both sides, we get 18. 18 divided by 3 leaves us with y is going to be greater than 6. On this side, we're going to subtract 1 from both sides. 2y is less than or equal to 6, and therefore our y is going to be less than or equal to 3. Now we have to graph. So now we're going to get our 6. So since y is greater than 6, let's put it down here. So everything, and remember the sign. So we're going to leave our circle open, and everything greater than 6 will satisfy this inequality. Y is less than or equal to 3. Therefore, we have our 3 right here. And remember the sign, so we're going to shade in our bubble. Then therefore, everything less than 3 is going to satisfy this equation right here. Now we have to combine both of these inequalities. Keep saying equations. These are actually inequalities. All right, so first thing we're going to do is graph our, I guess you could say anything pointing to the left. So which is this one right here. So we're going to have our 3 right about here, and everything less than it, remember the circle, everything less than it is going to satisfy this equation. Then we have our 6 pointing to the right. So our 6 would be about right here. And everything greater than it, remember your sign, open circle, everything greater than it is going to satisfy this equation. Now remember what I said about any given point on the number line. So let's say I choose a point right here. Let's say this is, I don't know, 10, right? Let's say that's 10. 10 will satisfy this equation. Inequality. 10 will satisfy this inequality, but not this one. But that's okay, because at any given point, just one inequality has to be true. Let's say I picked a point right here. Let's say this is 0. All right, so since 0 is that given point, 0 doesn't satisfy this inequality, but it does satisfy this one, which is okay because at any given point, just one inequality has to be satisfied. All right, guys, here's the final question. If you think you could do it, go ahead and pause the video and give it a try. If not, let's go ahead and work it out together. So here we have 2y minus 5 is less than -9, or -4y is less than or equal to 20. First thing I see is that or. all I'm thinking in my head is that at any given point, that point has to satisfy one of the inequalities. All right, so now we get there. So first we're going to go ahead and solve this inequality. Plus 5 on both sides, we get 2y is less than -4. And that means that our y is going to be less than -2. Then we get -4y is less than or equal to 20. So we divide by -4 on both sides, and we get that y is greater than or equal to -5, because remember, we flip the sign whenever we divide or multiply by a negative number. Now we graph. So here we have our y is less than -2. So we graph -2 right here. Remember, our greater than or less than sign is not a greater than or equal to sign. So therefore, we're going to leave our circle open and continue all the way down. So y is less than -2. Now on this side, we have a y is greater than or equal to -5. So therefore, our circle is going to be closed. It's going to be bubbled in, and then everything to the right of it, which means greater than, is going to satisfy this inequality. Now it's time to combine both of these, all right? So we combine them by placing them on this graph. All right, so we have our -5, right here. Remember, a closed circle, and everything to the right of it, all the way to infinity, is going to satisfy this inequality. Now here we have -2, open circle, because it's less than, right? No greater than or less than or equal to. So we have our -2 all the way here, open circle, and everything to the left of it, all the way to -infinity, is going to satisfy this inequality. So now we arrive at kind of like a mystery. So what happens when our two inequalities overlap? This is what we like to call all real numbers. So basically, any number on the number line from -infinity to +infinity is going to satisfy at least one of these inequalities at any given point. And there we have it. So I guess if you want a set answer in set interval notation, you just write -infinity is -infinity, comma, +infinity. That just means from all the way on the left side to the right. So basically the whole number line. All right, guys, if you need help with more math videos, make sure you click on the videos right here, subscribe, like, comment. What do you want me to do next? Let me know in the comments. And yeah, that's about it, guys. Stay safe, and remember, Jesus is coming back.